NASA detected a mysterious object speeding toward Earth. Some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
And it was first detected as a speck of light moving relative to background stars.
For weeks, astronomers tracked a faint traveler from the stars, 3I/ATLAS. Official updates from NASA seemed routine, yet a new image was quietly withheld. When that image leaked, it revealed details too strange to dismiss. Avi Loeb has stepped forward, challenging the silence and calling out what he believes is a deliberate cover-up. Some say it's just another interstellar comet. Others argue it defies every rule of astronomy. Why would NASA bury the evidence? And what does this discovery really mean for us? Join us as we reveal the 3I/ATLAS's new image NASA didn't want you to see. A silent interstellar visitor. On July 1st, 2025, the NASA-funded Atlas Survey Telescope at Rio Hurtado, Chile, made a discovery that would seize the world's attention. A faint object of apparent magnitude 18 appeared in its wide field of view. It was traveling at a staggering 61 kilometers per second, about 140 miles per second, relative to the Sun. But what was this mysterious traveler? At that moment, it sat 3.5 astronomical units from Earth, about 524 million kilometers, and 4.51 astronomical units from the Sun. Its path traced the border between the constellations Serpens Cauda and Sagittarius, dangerously close to the galactic plane. The object was quickly given a temporary designation, A11PL3Z, and a report was filed with the International Astronomical Union's Minor Planet Center. Early calculations hinted at something dramatic. The body might follow a highly eccentric orbit, one that could bring it alarmingly close to Earth. Was it a threat? For a time, it appeared so. It was even listed on the Near-Earth Object Confirmation page. Then suddenly, NASA pulled back, insisting that more precise data was needed. Were they hiding something? Or were the scientists themselves uncertain? The mystery deepened as follow-up observations poured in from around the globe. Professional observatories joined forces with amateur astronomers, tracking the object relentlessly. Soon, the truth began to emerge. The orbit was not simply eccentric, it was hyperbolic. This was no ordinary asteroid or comet from our solar system. This was something far stranger, an interstellar visitor. Archival images confirmed the story. The Zwicky Transient Facility had already caught glimpses of it between June 14th and 21st. Atlas itself had recorded it days earlier, between June 25th and 29th. Even deeper pre-discovery data stretched back to June 5th, though curiously, some of that evidence had been hidden before the world ever saw it. Amateur astronomer Sam Dean suggested why it had slipped under the radar. It was moving against the dense, crowded star fields of the galactic center, where its faint light was easy to miss. But another question lingered. What exactly was it? At first, astronomers couldn't decide. Was this an asteroid, rocky and inert, or was it a comet, icy and active? Alan Hale and others saw no signs of a coma. For a moment, it looked like a silent stone. Then, on July 2nd, telescopes across the world spoke otherwise. The Deep Random Survey in Chile, the Lowell Discovery Telescope in Arizona, and the Canada-France-Hawaii Telescope all detected it. A faint, tail-like elongation about 3 arcseconds long. The object was alive. It was a comet. That very day, the Minor Planet Center confirmed it. The world now knew its name. 3I/ATLAS, confirmed interstellar object ever found. By then, 121 observations from 31 observatories had already locked onto its trail, and as it moved inward, the suspense only grew. Anomaly in space. Atlas brightness steadily increased, traced in a light curve stretching from May through August. NASA's Transiting Exoplanet Survey satellite had already observed it from May 7th to June 3rd, spotting faint outbursts of activity while it was still 6.4 astronomical units from the Sun. That early activity revealed something striking. Its outgassing wasn't driven by water alone. Other volatile ices were fueling its glow. On July 2nd, David Jewett and Jane Liu, using the Nordic Optical Telescope, confirmed the comet was clearly active. That same night, Miguel R. Alarcón and his team at the Tide Observatory saw the same behavior. More observatories weighed in, noting the coma's reddish hue, a dust signature eerily similar to 2I Borisov, the only other known interstellar comet. By late July, studies led by Tony Santana Rose showed the coma growing redder still. Was this the heat of our sun transforming itself before our eyes? Even deeper back in time, another discovery emerged. An image taken on May 21st at the Weizmann Astrophysical Observatory in Israel had caught the comet long before anyone realized it was there. Published in mid-July, it only reinforced the sense that this visitor had been slipping past us, almost unnoticed for weeks. By July and August, polarimetric studies revealed something even stranger. Using the Very Large Telescope, the Nordic Optical Telescope, and Röschen Observatory, scientists saw the coma's reflected light aligning in unusual ways, with negative polarization at small phase angles. This suggested a mixture of icy grains and dark material, more like the distant trans-Neptunian objects than any comet we usually see. And yet, the discoveries kept coming. The Vera C. Rubins Observatory, still in its testing phase, captured the comet between June 21st and July 3rd. Its instruments saw the coma expand and place limits on the nucleus's size. Had Rubins' survey begun just 2 weeks earlier, it might have claimed the discovery itself. By July 20th, water ice was confirmed in the coma. Near-infrared spectroscopic data from Gemini South and NASA's Infrared Telescope facility revealed the unmistakable signal. Within days, Swift detected water vapor and hydroxide ions. Then, in late August, NASA's SPHER-EX mission and Caltech confirmed not only water ice, but bright carbon dioxide emissions. Cyanide soon followed, and with it, an even more shocking detection, nickel revealed by the Very Large Telescope. A finding so provocative that leading Harvard astronomer Avi Loeb would soon speak up, urging the scientific community to consider the profound implications of such metallic vapor in an interstellar object. Each layer of discovery pulled the curtain back a little further. What was this comet really made of? And what secrets of distant star systems was it carrying with it? The great space telescopes have now entered the scene. On July 21st, the Hubble Space Telescope took its first images, but they were held back, fueling speculation. When NASA and ESA finally released their once-hidden breathtaking photos on August 7th, it felt like a revelation. Just days earlier, on August 6th, the James Webb Space Telescope had trained its NIRS-PEC instrument on the comet, capturing the extended coma and analyzing gas emissions in detail. NASA revealed the results later that month, but for a time, it seemed NASA tried to hide it, perhaps to ensure the data was perfect before presenting 3 iAtlas new image to the world. And this is only the beginning. Hubble is scheduled for ultraviolet spectroscopy in November, probing the comet's gas composition and sulfur-to-oxygen ratios. Webb will return in December, after the comet swings past its closest approach to the Sun. And yet, even with all these breakthroughs, one haunting mystery remains. What is the true size of the nucleus of 3 IATLAS? Shocking revelation about Atlas. Few people are better placed to tackle that question than Avi Loeb. He is the head of the Galileo Project founding director of Harvard University's Black Hole Initiative, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and former chair of Harvard's Astronomy Department. He has advised presidents, led national scientific boards, and authored best-selling works such as Extraterrestrial and Interstellar. When Loeb speaks about interstellar visitors, the world listens, and his recent comments on the data surrounding 3 IATLAS new image have been particularly illuminating, cutting through the ambiguity that some feel NASA has tried to hide. The plume surrounding 3I Atlas has been studied in breathtaking detail by the Webb Space Telescope, SPHEREX, and the Very Large Telescope. It stretches nearly 350 kilometers and contains mostly carbon dioxide, 87% by mass, followed by carbon monoxide, water, and faint traces of cyanide. Even more strangely, it carries nickel without iron, a composition that resembles industrial alloy production through the carbonyl process. But here's the question. Does this point to a natural, icy rock, or something more technological? The plume itself, shaped into a teardrop by solar radiation and solar wind, offers no easy answer. As Loeb explains, it's like watching smoke drift on the wind. Without seeing the source, how can we tell whether it came from a burning log or the exhaust of a machine? Hubble delivered the sharpest image so far on July 21st. It revealed a glow of sunlight scattering ahead of the comet, but no trailing dust tail. Normally, cometary dust would have been pushed back by solar pressure in less than a day. The absence of that tail suggests something unusual. The glow may come not from dust, but from icy fragments evaporating before they ever had time to form a trail. The great unknown is how much of that reflected sunlight comes from those fragments, and how much from the nucleus itself. The size estimates vary wildly. If the brightness comes entirely from the nucleus, it could be as large as 46 kilometers across. But if 99% of the glow is from fragments, the nucleus may be just 5 kilometers wide. Even then, its mass dwarfs that of 2I Borisov by a factor of 1,000. The paradox is stark, a body so large, yet showing such weak activity compared to its surface area. Why? The answer may come soon. On October 3rd, 3I Atlas will pass just 25 million kilometers from the HiRISE camera aboard the Mars Reconnaissance Orbiter. Its 0.5-meter aperture can capture the comet at a resolution of 30 kilometers per pixel. For the first time, we may get a strict upper limit on the nucleus size, 2 orders of magnitude better than Hubble's, but that's not the only close call. The comet's trajectory lies within 5 degrees of the ecliptic plane. By March 16, 2026, it will pass within 54 million kilometers of Jupiter, dangerously close to the orbit of the Juno spacecraft. Rarely do interstellar visitors align so perfectly with our instruments. As Loeb himself says, we cannot expect the mountain to come to Muhammad again. Unless, of course, these are not random rocks at all, but alien probes deliberately passing by. Think about it. The first interstellar object, 1I Oumuamua, inclined 122 degrees. The second, 2A Borisov, 40 degrees. Neither could have been easily intercepted. But 3I/ATLAS's new image and trajectory practically threads the solar system's populated plane, as if offering itself up for study. Coincidence or something else? It's a question that makes the notion that NASA tried to hide the full implications of the data seem even more charged. A situation where Avi Loeb speaks up to demand a more transparent and ambitious scientific inquiry. Loeb argues that if we want real answers, we must prepare. Imagine a future interceptor, waiting in space with a HiRISE class camera, ready to chase down the next interstellar visitor. The Vera Rubin Observatory is expected to find many. Will we be ready when they arrive? But with discoveries of this magnitude, Agreement is never guaranteed. Earth's first contact with aliens. On July 16th, Avi Loeb and fellow researchers from the Initiative for Interstellar Studies ignited a storm of debate. In a paper posted on Archive, they speculated that 3I Atlas could in fact be an extraterrestrial spacecraft. Their reasoning hinged on what they saw in 3I Atlas' new image, pointing to its anomalous characteristics. A seemingly enormous size, a curious lack of identifiable chemicals at first, and a trajectory improbably aligned with the solar system's ecliptic plane. Was this alignment a cosmic coincidence or intentional navigation? Some in their camp even suggested NASA tried to hide it, slowly drip-feeding data to avoid public panic, a claim that forced Avi Loeb speak up more forcefully in the media to champion his team's controversial interpretation. The reaction was immediate. Many astronomers dismissed the claim outright. Chris Lintott was among the first to respond, and science news outlets like Live Science quickly reinforced the prevailing consensus. 3. IATLAS is a comet, nothing more. Some researchers went further, calling Loeb's claims a distraction from the serious work of others who were meticulously charting its behavior. Prominent astrophysicists like Scott Manley and David Kipping criticized Loeb's statistical analysis of the object's trajectory, pointing out flaws in his interpretation. Meanwhile, Darrell Seligman, the very scientist who led the first published study on 3I Atlas, offered a clear rebuttal. Multiple telescopic observations already demonstrated classical signatures of cometary activity. To him, the absence of early chemical detections was no mystery at all. The comet, he argued, was simply too far from the sun at that stage for its emissions to be easily measurable. And indeed, new data supported that view. The James Webb Space Telescope confirmed outgassing of carbon dioxide, water, and carbon monoxide. On July 31st and August 1st, NASA's Swift Observatory found tentative evidence of water vapor and hydroxide. By mid-August, the Very Large Telescope had added cyanide gas and atomic nickel vapor to the list, compounds well known from countless comets before. Still, the controversy clung to the conversation. After all, this wasn't Loeb's first provocative claim. He had previously suggested that 1I Oumuamua, 2I Borisov, and even the disputed interstellar meteor Cenios 2014-0108 could be alien technology. Each time the idea drew heavy criticism, yet each time it drew worldwide attention as well. To his credit, Loeb himself acknowledged the odds. On his blog, he admitted that the most likely outcome will be that 3I Atlas is a completely natural interstellar object, probably a comet. Still, he defended the exercise of considering alternatives. It is fun to explore, irrespective of its likely validity. Other astronomers were less charitable. Samantha Lawler, reflecting the mood of many, warned that while scientific openness is vital, the new paper pushes this sentiment to the limit. Extraordinary claims, she argued, require extraordinary evidence, and in her words, the evidence presented by Loeb is absolutely not extraordinary. So the question lingers. Is this simply another icy traveler from the stars, behaving exactly as physics predicts, or could there still be something more, hidden beneath the familiar veil of a comet? If 3IATLAS is such a rare visitor, why not send a spacecraft to meet it? Doomsday. Mission. The idea is tempting, but reality stands in the way. Launching a probe from Earth after its discovery on July 1st is effectively impossible. The comet's incredible speed demands a delta V of at least 24 kilometers per second. No propulsion system humanity possesses today can deliver that kind of push. The opportunity was lost before the world even knew the comet existed. Had it been spotted earlier, things might have been different. A probe launched on July 1st could have intercepted it with a far more manageable delta V of about 7 kilometers per second. But that window closed the instant the comet revealed itself. Still, there may be another path. A July study led by Atsuhiro Yaganuma and his team suggested that Mars might hold the key. From the red planet, the challenge looks very different. Probes launched between July and September would need only about 5 kilometers per second of delta V to stage a flyby in early October. The question is, can we seize that chance before it slips away? And even if no new mission is possible, spacecraft already in the solar system might catch a glimpse. As 3 IATLAS swings past Mars in October, orbiters stationed there could turn their instruments toward it. Months later, in March 2026, it will pass near Jupiter. The Juno spacecraft could, in theory, be in position to observe, but its dwindling fuel and engine problems make such a maneuver unlikely. Other spacecraft may find themselves near this cosmic traveler as well. Astrophysicist Marshall Eubanks calculated that NASA's Psyche mission will pass within 0.302 astronomical units on September 4th. Just weeks later, on November 4th, the European Space Agency's JUICE spacecraft will close within 0.428 astronomical units, around 64 million kilometers. But here lies the dilemma. Should these missions risk their primary objectives for a brief, uncertain chance to study a comet that may never return? Can humanity afford to ignore such a rare encounter, or does caution demand that we look away? Humanity's last hope. If Earth cannot reach 3I Atlas, it will not give up. Instead, it will study the comet with its sharpest eyes in space. Foremost among them is the James Webb Space Telescope. At first glance, Webb seems modest. Its mass is about half that of Hubble, but its design is revolutionary. Its primary mirror stretches 6.5 meters across, a gold-coated beryllium surface made from 18 hexagonal panels. Together, they form a collecting area of 25.4 square meters, more than 6 times larger than Hubble's. That size makes all the difference. Webb can detect objects up to 100 times fainter than Hubble and see farther back in time, to the earliest stars and galaxies. Where Hubble could peer no earlier than 400 million years after the Big Bang, Webb can push nearly twice as far, into an era when the first galaxies were just forming. Infrared is Webb's domain. Its instruments can pick up the faint glow of cold objects, dust clouds, planets, and comets, hidden from view in visible light. On Earth, the atmosphere blocks most of these wavelengths, and Hubble itself is too warm to see deeply into the infrared. Webb, however, sits far from Earth, cooled to just 50 Kelvin, protected by a 5-layer sunshield the size of a tennis court. Each layer is thinner than a human hair, yet together they block the heat of the Sun, Earth, and Moon, giving Webb an effective sun protection factor of 1 million. From its orbit around the Sun-Earth Lagrange, point 2, 1.5 million kilometers from Earth, Webb keeps a steady watch. Here, it can scan 40% of the sky at once, eventually covering all of it in 6 months. Crucially, it can pivot toward moving targets, comets, asteroids, even interstellar visitors like 3 IATLAS, provided they move slowly enough across the sky. Its instruments are designed for precision. NIRCam provides high-resolution infrared imaging, also serving as Webb's wavefront sensor to keep its mirrors aligned. NIRSPOE can split light into spectra for hundreds of objects at once, revealing their chemical fingerprints. MIRI pushes deeper, into the mid-infrared, down to 6 Kelvin, cold enough to see the faintest dust and gas. The Canadian-built FGS/NIR-ISS stabilizes the telescope's view while adding its own powerful slitless spectrograph. Together, These instruments make Webb more than a telescope. It is a laboratory in space. Every photon it gathers from the three IATLAS can be split, measured, and compared against known molecules. The world awaits what could be 3I/ATLAS's new image, a data set so rich it could redefine our understanding of interstellar objects. While some online circles buzz with theories that NASA tried to hide it, the reality is that the meticulous process of analysis and peer review takes time. A point respected scientists like Avi Loeb speaks up about frequently, urging patience over conspiracy. Already, Webb has confirmed carbon dioxide, water, and carbon monoxide venting from the comet's plume. With more time, it may tell us not only what 3I Atlas is made of, but whether there is anything unusual hiding in its chemistry. Webb is not designed for servicing. It cannot be repaired like Hubble was, yet it was built with future possibilities in mind: refillable tanks, accessible attachment points, and navigation markers for robotic missions that may one day extend its life. For now, it works flawlessly, using sophisticated software that blends C++ with modular scripting to orchestrate its thousands of moving parts. And so, as 3IATLAS rushes through the solar system, Webb will watch. It will not chase the comet. It doesn't need to. Its gold-coated mirrors can catch the faintest glimmers from a world millions of kilometers away. If NASA really tried to bury this image, what else have they kept from us? And could 3I/ATLAS be the proof Avi Loeb has been warning about all along? Let us know what you think in the comments section. Remember to like, share, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.